Hey everyone, and welcome back. Today we are going to be taking a deep dive into something that you might not think about every day.
Oh, okay.
How cargo ships are trying to become more eco-friendly.
Interesting.
Yeah, so specifically, we're going to be focusing on energy efficiency and its role in making shipping greener.
Okay.
We've got a DNV guidance paper on exactly this, and it is packed with insights on how ships can cut emissions, right now, and how they can get ready for the future of carbon-neutral fuels. But here's the thing.
Yeah.
The supply of those fuels just isn't there yet. So making ships more efficient is absolutely crucial.
What's interesting is that this isn't just about tinkering around the edges.
Yeah.
The International Maritime Organization, the IMO, has set some seriously ambitious goals.
Okay.
We're talking a 20% reduction in emissions by 2030, 70% by 2040, and by 2050. The goal is full decarbonization.
Wow, that's a pretty aggressive timeline.
It is.
So how does energy efficiency actually fit into this whole decarbonization puzzle?
Well, energy efficiency is a powerful tool for reducing emissions in the short term.
Okay.
If a ship burns less fuel, it emits less.
Right.
Pretty straightforward, right?
Yeah.
But the real kicker is that energy efficiency also sets the stage for a smoother transition to those new, cleaner fuels we were talking about.
So it's not just a temporary fix, it's a long-term strategy.
Exactly.
Okay.
See, these carbon-neutral fuels are going to be more expensive than the fossil fuels we use today.
Right.
So if you can squeeze more miles out of every drop of fuel now, it makes those future costs much more manageable. Plus, DNV predicts that the shipping industry will need a huge chunk, about 25 to 30% of the global supply of these new fuels by 2030.
Okay. I'm starting to see why energy efficiency is so important, but what does it actually look like in practice? Are we talking about futuristic engines or something?
It's actually a combination of things.
Okay.
Some of it is high-tech.
Yeah.
But there are also some surprisingly simple solutions that can make a big difference. For example, something as basic as keeping a ship's hull clean can significantly boost its fuel efficiency.
Really? Just by cleaning it?
Yeah.
How does that work?
Well, when a ship's hull gets covered in barnacles and algae, what's called hull fouling, it creates a lot of drag in the water. It's like trying to run a marathon with weights strapped to your ankles.
Right.
Regular cleaning can reduce drag, making the ship glide through the water much more easily.
Okay.
DNV's research suggests that regular cleaning can boost efficiency by 3 to 7% and sometimes even more.
Wow.
It's a low-cost way to see a real improvement.
That makes a lot of sense. It seems like common sense. But I guess it's easy to overlook the simple things.
You're absolutely right, and it's not just about cleaning. You can also optimize the hull's shape for better hydrodynamics.
Okay.
Think of it like streamlining a race car to cut through the air more efficiently. DNV has actually been doing some pretty cool work with bulbous bow retrofits, essentially reshaping the front of the ship.
So it's like giving the ship a nose job.
Yeah, in a way.
Okay.
And these retrofits can reduce resistance by up to 15%, leading to significant fuel savings.
Okay, so we've covered cleaning and reshaping the hull. What else is there?
Well, there's been a lot of buzz lately about wind-assisted propulsion systems, or WAPS for short.
Okay.
These are essentially modern takes on sails designed to harness the power of the wind and reduce reliance on the ship's engine.
I've seen pictures of those.
You have.
They look pretty cool.
Yeah.
Kind of like futuristic sails. Are they actually effective, though?
They're more than just a pretty sight.
Okay.
We're seeing some really promising results. There are a couple of main types of WAPS. One is the Flettner rotor, which is a tall spinning cylinder that creates thrust using the Magnus effect.
Okay.
The other main type is the wing sail, which, as the name suggests, is a rigid sail shaped like an airplane wing.
Right.
Both of these technologies are being installed on ships right now.
I'd love to know more about them.
Yeah.
But I'm guessing there are a few other tricks up the industry's sleeve.
Absolutely. There's also air lubrication systems, or ALS, which use air bubbles to reduce friction between the hull and the water.
So it's like the ship is gliding on a layer of air that sounds almost too good to be true.
It's a bit more complex than that.
Yeah.
But the basic idea is to reduce friction, which means less energy is needed to move the ship.
Okay.
DNV estimates that ALS can reduce fuel consumption by up to 8%.
Wow.
They're even developing guidelines to verify that these systems are working as effectively as possible.
It sounds like there's a lot of innovation happening in this field. What else can ship owners do to improve energy efficiency?
Well, believe it or not, one of the biggest areas for potential improvement is the human factor.
Oh, interesting.
Yeah.
I wouldn't have thought about that. How can the crew make a difference?
There are a lot of small decisions that add up.
Oh.
Think about things like adjusting the autopilot, optimizing the ship's trim, or even choosing the most fuel-efficient route based on weather conditions.
Right.
Studies have shown that crew awareness and training can unlock up to 10% in energy savings.
Wow, that's a huge impact. It's a good reminder that even in a high-tech industry, like shipping the human element is still incredibly important.
It really is, and there's actually a pretty amazing example of this.
Oh.
There is a container vessel that had irregular speed patterns over just 3 months, and guess what? It ended up costing them an extra $500,000 in fuel.
That's a pretty expensive lesson in fuel efficiency. I'm starting to see how all these pieces fit together.
Yeah.
So we've got these new technologies, we've got the importance of the crew, but how do ship owners actually put it all together into a plan?
That's a great question, and it's where things get even more interesting. But let's save that for the next part of our deep dive.
Sounds good.
Yeah.
I'm definitely curious to hear more about how this all comes together in practice. All right, so we've talked about all these individual pieces of the puzzle,
Right.
from cleaning hulls to futuristic sails.
Yeah.
But I'm really curious about how ship owners bring it all together. It seems like a daunting task.
It definitely is, but there's a roadmap for ship owners to follow. The DNV has a really helpful tool called the pathway model, which guides them through the process. It starts with defining their greenhouse gas goals, both what's required by regulations like those from the IMO,
Right.
and what encouraged by commercial agreements like the Poseidon Principles.
So they've got to balance the rules with what makes good business sense.
Exactly. And then they need to assess different pathways to meet those goals.
Okay.
That's where the pathway model comes in. It helps ship owners weigh their options from energy efficiency measures to fuel choices to even onboard carbon capture. The model takes into account things like the type of ship, how it's used, and of course, cost.
So it's not a one-size-fits-all plan. It's tailored to each ship owner's unique situation.
Exactly. It's a dynamic roadmap that can adapt as new technologies emerge or market conditions change.
That makes sense. But even with a plan in place, I imagine there's a huge difference between having a plan and actually putting it into action.
You're absolutely right. It's not just about installing new tech. It's also about setting clear procedures, training the crew, and putting monitoring systems in place. It's crucial to have a feedback loop so that ship owners can track their progress and make sure they're on track to meet their goals.
It sounds like data is playing an increasingly important role in this whole process. It's like we were talking about earlier with the crew. Those seemingly small decisions can have a big impact.
Data is absolutely essential. It helps ship owners make informed decisions and measure the effectiveness of their efforts. For instance, remember how we were talking about the impact of hull fouling on fuel efficiency?
Right.
Well, data analysis can help ship owners optimize their cleaning schedules. To maximize savings, it can even help identify irregular speed patterns that are wasting fuel.
Right. It was pretty shocking to hear that a ship could lose $500,000 in just 3 months from inconsistent speeds.
It's a stark reminder of how much potential there is for improvement. Speaking of potential, we talked about wind-assisted propulsion systems earlier, and I'm really curious to hear more about them. They seem like a game changer.
They really do.
Yeah.
It's fascinating how these systems are essentially modern-day versions of sails.
Right.
Using the wind to help power massive cargo ships. We touched on Flettner rotors and wing sails earlier, but can you give us a little more detail on how they actually work?
Of course, let's start with Flettner rotors. Imagine a tall spinning cylinder mounted on the ship's deck.
Okay.
Now, when wind flows past this spinning cylinder, it creates an area of low pressure on one side and high pressure on the other. This pressure difference generates a force perpendicular to the wind direction, which helps propel the ship forward.
So even if the wind isn't blowing directly behind the ship, these rotors can still capture its energy.
That's the amazing part. It's a much more versatile way to harness wind power compared to traditional sails.
Wow.
The other type of WPS wing sails works a bit differently. As the name implies, they resemble airplane wings.
Okay.
These rigid sails generate lift, just like an airplane wing, which pulls the ship forward.
So it's essentially using aerodynamics to harness the power of the wind.
Exactly. And both Flettner rotors and wing sails are already being used on ships today.
Oh, wow.
For example, the SC connector, a roll-off ro-ro vessel, has been retrofitted with 2 Norse Power Flettner rotors, which can reduce fuel consumption and emissions by up to 20%.
That's impressive. And what about wing sails? Have those been successfully implemented as well?
Absolutely. The Pyxis Ocean, a bulk carrier, has been fitted with 2 Bayar technologies, wind wings.
Okay.
These massive sails, each standing 37.5 meters tall,
Wow.
are made of a lightweight composite material and can reduce fuel consumption by up to 30%.
That's remarkable.
Yeah.
It's really exciting to see these technologies actually being put into practice and making a difference.
Yeah.
But it sounds like wind power is just one piece of the puzzle.
Right.
Are there other innovative solutions being explored?
There are. One technology that we touched on earlier is air lubrication systems.
Right.
It might sound futuristic,
Yeah.
but it's a clever way to reduce friction between the ship's hull and the water.
I remember you saying it's like the ship is gliding on a layer of air. How does that actually work?
It involves pumping compressed air through a network of pipes that run along the bottom of the hull.
Okay.
As the ship moves, these air bubbles rise and form a thin layer between the hull and the water, reducing friction and drag.
It's like giving the ship its own personal slip and slide.
That's a great way to put it.
Okay.
And it's proving to be quite effective. Major shipping companies like MSC and Maersk are already implementing air lubrication systems on their vessels.
Oh.
And DNV estimates that they can reduce fuel consumption by up to 8%.
Wow. 8% is nothing to sneeze at. It seems like there's a whole wave of innovation happening in the maritime industry right now.
Yeah.
Must be an exciting time to be involved in this field.
It definitely is. And what's even more exciting is that we're just at the beginning of this journey.
Yeah.
There are so many possibilities and so much potential for further innovation. But with all these cool new technologies, sometimes we forget about the tried and true methods that can also make a big difference.
You're right. We were talking earlier about the importance of the crew.
Mm-hmm.
But what about the engines themselves? Are there ways to optimize those for better fuel efficiency?
Absolutely. There are a number of things that can be done, from simple adjustments to more complex upgrades.
Okay.
One strategy is engine derating,
Okay.
which essentially involves reducing the engine's maximum power output.
Mm-hmm.
It might sound counterintuitive, but it can actually lead to significant fuel savings.
So it's like choosing a lower gear in your car. It might feel less powerful, but it can save you a lot of fuel in the long run.
Exactly. And then there are things like variable engine speeds,
Right.
and frequency drives for auxiliary systems like pumps and fans.
Okay.
By optimizing these systems, you can squeeze out even more energy savings.
It seems like every little bit counts when it comes to fuel efficiency. And speaking of every little bit counting, we were talking earlier about the impact of the crew.
Right.
But I'm curious to dig a little deeper into that. What specific actions can the crew take to make a difference?
There are a lot of small things that can add up to big savings. One example is autopilot adjustment.
No.
A well-tuned autopilot can maintain the ship's course with fewer and smaller rudder movements, reducing drag and fuel consumption.
It's like the difference between a smooth driver and one who's constantly jerking the steering wheel.
Exactly. And then there's trim optimization,
Okay.
which involves adjusting the ship's angle in the water for optimal hydrodynamics.
Mm-hmm.
Think of it like finding the sweet spot for how the ship sits in the water.
So it's like finding the perfect balance for a surfboard.
That's a great analogy. And let's not forget about weather routing, which is essentially like using a GPS for ships, but with fuel efficiency in mind.
Okay.
By choosing routes that minimize fuel consumption based on weather conditions, ships can save a significant amount of fuel.
It's amazing how even small adjustments can make a real difference. But all of these things, the technology, the crew, training, the operational tweaks, they all require a shift in mindset, don't they?
Absolutely. It's not just about adopting new technologies, but also about embracing a culture of energy efficiency.
Right.
And it's about recognizing that sustainability and profitability can go hand in hand in the long run. The most successful shipping companies will be those that prioritize both.
That makes a lot of sense.
Yeah.
So we've covered a lot of ground today, from cutting-edge technologies to the importance of the human element. But as we wrap up part 2, I'm just wondering, what's the big picture here? What's the ultimate goal of all these efforts?
Well, the ultimate goal is a carbon neutral shipping industry.
Okay.
And while we focused on energy efficiency in this deep dive,
Right.
it's important to remember that it's just one piece of the puzzle.
Yeah.
We still need to transition to cleaner fuels and continue to innovate and develop new technologies. But energy efficiency is a crucial stepping stone on that path.
Okay.
It allows us to make progress today while we work towards a more sustainable future for shipping. And with that, I think we've reached a good point to pause our deep dive.
I agree. This has been a really insightful conversation, and I'm definitely looking forward to picking it up again in part 3. Welcome back to our deep dive into energy efficiency in the world of shipping. It's been quite a journey so far, hasn't it?
It really has. We've gone from the basics of hull cleaning all the way to futuristic sails and air lubrication systems. It's clear that there's a lot happening in this space.
Absolutely. And I think one of the most interesting things we've touched on is the idea that energy efficiency isn't just about fancy new technology.
Right.
It's also about smart planning, operational tweaks, and even the decisions made by the crew on board.
You're spot on. It's a holistic approach.
Yeah.
And, makes me think about the bigger picture here. We've talked a lot about the how of energy efficiency, but I think it's equally important to consider the why.
That's a great point. Why should ship owners, and really all of us, care about making shipping more energy efficient?
Well, on a practical level, it's about reducing costs. Fuel is a major expense for shipping companies, and with prices constantly fluctuating, anything they can do to reduce consumption is good for their bottom line.
That makes sense, but it's also about more than just saving money, right?
Absolutely. It's about reducing our environmental impact.
Right.
Shipping is a major contributor to global greenhouse gas emissions, and as we've discussed, the IMO has set ambitious targets for reducing those emissions. Energy efficiency is a crucial tool for meeting those targets.
It's like we were talking about earlier with the supply and demand issue for those new carbon neutral fuels. By making ships more efficient now.
Right.
We're not only reducing emissions today, but we're also paving the way for a smoother transition to a cleaner future.
Exactly. It's about creating a more sustainable industry, one that can continue to support global trade while minimizing its environmental footprint.
It feels like there's a real sense of momentum building in this area. More and more shipping companies seem to be taking this seriously.
I agree, and I think a lot of that has to do with the fact that sustainability is no longer just a nice to have. It's becoming a business imperative.
Yeah.
Consumers are demanding it, investors are prioritizing it, and regulations are increasingly requiring it.
So it's really a win-win situation.
Yeah.
Ship owners can reduce costs, improve their environmental performance, and enhance their reputation.
Yeah.
But let's be realistic. There must be challenges too, right?
Of course, one of the biggest challenges is the upfront cost of implementing some of these energy efficiency measures.
Okay.
Retrofitting a ship with new technology can be expensive, and there's always a risk that the investment won't pay off as quickly as hoped.
So it's a balancing act between short-term costs and long-term benefit.
Exactly. And there's also the issue of complexity.
Okay.
The maritime industry is incredibly complex, with a vast network of stakeholders, from ship owners and operators to ports and regulators. Getting everyone on board with these changes can be a challenge.
It sounds like communication and collaboration are key.
Absolutely. And I think we're starting to see more of that. There are a number of industry initiatives and partnerships focused on promoting energy efficiency and developing best practices.
That's encouraging. So as we look ahead, what do you think the future holds for energy efficiency in shipping?
I think we're going to see continued innovation and adoption of new technologies.
Sorry?
Things like artificial intelligence and machine learning are already being used to optimize ship operations and improve fuel efficiency. And as those technologies mature, they're only going to become more powerful.
That's exciting, but it's not just about the technology, right?
Yeah.
We've talked about the human element, the role of the crew, and the need for a culture of efficiency.
You're exactly right. The human factor will continue to be crucial.
Yeah.
We need to invest in training and education to ensure that crews are equipped with the knowledge and skills to operate ships as efficiently as possible.
It's a reminder that even in a high-tech industry, people still make a huge difference. So as we wrap up our deep dive, I'm curious, what's your biggest takeaway from all of this?
For me, the biggest takeaway is that energy efficiency is not just a technical challenge, it's a systemic one. It requires a shift in mindset, a willingness to collaborate, and a commitment to continuous improvement.
That's a great way to put it, and it applies not just to shipping, but to so many other industries facing similar challenges.
Absolutely. If we can apply these same principles in innovation, collaboration, and a focus on the human element, we can make significant progress towards a more sustainable future across the board.
Well, on that note, I think we've reached the end of our deep dive. It's been a fascinating journey, and I've learned so much.
Me too. It's been a pleasure discussing this with you.
And to all of you listening, thank you for joining us on this deep dive into the world of energy efficiency in shipping. We hope you found it as insightful as we have. Until next time, keep exploring and keep learning.